Then some of this has come from the way your book defines things. It says, inconsistent dependent systems. Definition. A consistent system is a system that has at least one solution. I would not say, well, at least it has only one. Well, yeah, it had at least one solution. Independent system is where the lines are independent of each other. Now that's still consistent. Coincident lines are identical lines that have equal slopes and the same y-intercept. What they're saying is this guy here, if they're coincident lines, they are the same line. I hate big words. They didn't have to do that. And when independent system, what they're really saying is these guys have different slopes. The lines are independent of each other. That's what that means. Dependent system is a system where one line depends on the other. The system has an infinite number of solutions. It really is the same thing as the coincident lines. Just means they are the same lines. And let me break this down for you. This comes from my intermediate algebra. If you're looking at systems of equations, 2 equations and 3 unknowns, 3 things can happen. You can have what they call independent. In other words, in this particular instance, I have lines that have different slopes. Doesn't matter about the y-intercept, they have different slopes. That's the issue. The type we normally call consistent. And the number of solutions, and I was going to change this, I didn't. The number of solutions, it has 1. So that says if it has different slopes, it's only going to cross in one place, period. It's going to have one solution. Now, when I take a look at this situation, the lines are parallel. That means they never cross. So what do they have? They have the same slope, and they have different y-intercepts. Same slope, different y-intercepts. They never cross. This system is called inconsistent. Now, if you take any English at all, a prefix of in means not. So if it's not consistent, it has no solution. They never cross. So they are inconsistent. There is this one that they call coincident lines or a dependent system. So these are the same lines. So what do they have? Same slope, same y-intercept. Same slope, same y-intercept. This is type is dependent, and the number of solutions are infinite. So it has an infinite number of solutions. What do the lines have in common? The line itself. So the solution is the line, which is an infinite number of xy coordinate points that form it. And then your book gave you a series of problems which says determine the number of solutions by writing the equations in slope-intercept form, and that's why I did this. The minute the slopes are different, you have one solution. If the slopes are the same but have different y-intercepts, you don't have any solutions. And if basically they're the same line, you have infinitely many solutions. Same slope, same y-intercept. They're the same. So that's a series of problems they ask you to do. Some are easier to do than others, like this guy. If I write him in slope-intercept form, that says y equals 4x minus 5. This one says that y equals 1/2 x plus 2. What do I notice? What I notice about the slopes? They're different. So I say different slopes. They don't want you to solve them. Different slope, not different slopes. Different slopes. One solution. That means if I graph it, it looks like this guy up here. This says that 3y equals negative 6x plus 9 divided by 3, y equals negative 2x plus 9. So that's the first line. The second one says that y equals negative 2x plus 7. So what do you notice? Same slopes, right? But what do you notice about the y-intercepts? One's a 9, one's 7. They're different, right? That means that these guys are parallel. So there's no solution. Or 0 solutions.
What did you get, 3 for the top one?
3 for the top one.
Because you got still plus.
Divide by 3. You would get negative 2x. Oh, that should be a 3. I see what you mean, yeah. So they're still different. That's good news. Whew. So there's no solution. And multiply through by negative 1, and you get y equals negative 6x plus 22. So that's your top guy. Bottom guy would say that 1/2 y equals negative 3x plus 11. Solve for y, that means multiply everybody by 2. You'll get that y equals negative 6x plus 22. So the second guy is also y equals negative 6x plus 22. So same. So they are the same line. So that means there are an infinite number of solutions.